Yeah. Okay. Okay, and so today we will work on the Unit 4 practice test. There are typo here. It should be Unit 4. Chapter 9 and Chapter 10 um, Chapter 10 in my lecture note, or Chapter 12 in the textbook. Okay, we will use 10 instead of 12 to make it consistent. So Chapter 9, Chapter 12, 10, or 12 in textbook, which is what we did was um, we learn how to use statistics to perform a hypothesis testing problem, how to use the data to support a certain research claim, right? Uh, which is in Chapter 9 about hypothesis testing, and Chapter 12 is about prediction. And we learn the most basic type prediction with a linear regression. So you can see that here we have everything, right? In Chapter 9, it's segmented by null and alternative hypothesis. So basically, the task here we need to specify what is the null, what is the alternative correctly, and then what is a type 1, type 2 error, and then a decision where you perform a test and make a decision, right? And here's some example with the data. So basically for testing here at our level, we focus on two kind of tests. One test for proportion. When people talk about percentage, the proportion, and another test for the mean. And we just focus on a case like testing for mean when sigma unknown, which is we will be using a t-test. Because this is also the case happens most of the time in real life. And then go to a linear regression. We have an example problem for, here it's just a review for, decide what slope intercept, and then construct scatter plot, and specify whether we have strong or weak correlation between the data. And then we go to regression equation. And the good thing is that with a linear regression equation can be obtained from your TI calculator, so you don't need to do manually calculation here, and then use it to do prediction, right? So let us just walk through each problem in the unit 4 here. So for the first problem, identify the known alternative hypothesis. So again, here you should remember that the alternative is a research claim and the thing we want to support, right? And the null is the thing with stick with the equal sign for our level. So in this problem, they ask us to identify the known alternatives using the correct notation. So which means we need to be able to recognize whether we talking about the that is from mean or proportion. Also identify it will be a left tail, right tail, or two tail. So this is important, right? Because if the first step here is wrong, and there's no point to move any further. Okay, you should be able to specify this problem correctly. Then know the alternative and whether it's the right tail, left tail, or two tail. And this way, how it help you to make a correct decision, right? So here a school principal claims that the average test score of student in her school is higher than national average 2025. So the keyword here is we have let's use this. Yes, this is the keyword here, the claim, right? Claim. Mhm. Okay, good. Now it works now. So the claim here, which is the thing we want to support, the average, right? So we were talking about the mean, right? Average test score of student in her school is higher than the national average. So if you denote mu by the average of test score per student, right? A student in her school, and basically like the alternative one support would be mu greater than 75 because it's higher, right? Higher than. So it's the national average, right? 75. And which it left your no be h naught mu equals 75, right? So the second one, belief, right? Researcher belief. Proportion of people, proportion. So which means we're testing for P proportion. Who prefer online shopping over in-store shopping has decreased from the last year proportion. Has decreased. Decreased from what? Last year proportion, which is 40%. So which means if you didn't know, by P is the proportion of people who prefer shopping online over shopping in store. So at the time, the alternative, the research uh, we want to support, the claim was support will be P, it decrease, right? And decrease compared to what? So decrease compared to last year, right? So decrease, which means the proportion now getting smaller. So maybe last year 40%, this year only 30%, right? And which means it left you the alternative, which is the no hypothesis, which is this, right? A research thesis claim that the average, right? So here we're talking for mu. IQ in the United States is no longer 100 point average. The 100 point average it has always been thought to be. Okay, it's a little bit like wording, but basically it no longer the 100 average. It no longer. So which means it's maybe less than, it's more than. In eventually people get smarter. The IQ higher. I get in more, little bit not smarter, right? Which is yeah. In this case, maybe we use just too much social media. So in this case, basically we want to test for the meal no longer than, right? So basically different, right? Yeah. So this is your HA, right? Where's such? Right. H not. Okay. Okay, so let's check if we have solution correct. Then yeah, it's correct. Oh, we also need to decide whether it's a right tail, left tail, two tail, right? So this is the greater than, right? Which is the right tail test, right? Right tail. Because the region you can help you to support the alternative will be this region, right? You testing for mean, you collect the sample data, X bar. So if your X bar way big in this side, right? And which means it will support the hypothesis alternative, which is mu greater than 75. So say if we collect data from our students, right? And we find out, oh, if we collect maybe 10 students, we see, oh, the average in this school is about 92, which is way higher than 75, right? So which means you can support, right? And maybe you see, oh, it's 99.9. I just choose random 9 students and I found that, oh, so which means very super school, right? It's super school. So similarly, right? So this is the left, so this is the right tail, right? Right tail. Similarly, this is the left tail, right? Left tail. So you may survey like 10, 100 people, and you find only one person, prefer online shopping over. So which means something wrong, right? It getting smaller. People get back to like, prefer enjoy the in-store shopping to relax more, right? Kind of, they walk outside and they enjoy the fresh air and whatever, right? And here is because it's different, right? So it's a two-tail. Okay, so see the next one. Assume the no hypothesis is not jack got enough money to afford luxury apartment, right? So basically like the A naught is that Jacob earn enough money, right? So basically, probably his income will be more than a certain threshold, right, to be able to make it happen, right? Which is say the mean income, right, greater than say me $100,000 per year, something like that, right? So this means he can afford for a luxury apartment, and versus not so, right? Which is his income is less than a certain threshold, right? Jacob not earn enough money. So for luxury, right? Luxury apartment. So this is your AH, the opposite, right? Apartment. So Taiwan error, it happened when the no correct, but I use the sample data, right? We reject the no. So you should recall that the Taiwan error is a problem, the third error which is reject a notch when A is not true, right? So this is the definition. So which means in this case you reject the hypothesis that Jacob earning enough money, right, for a luxury apartment, while actually he earn enough money, right? So basically in this case, you reject a notch which you support AH. So you can also say like uh, you make the conclusion that Jacob not earn enough money, right, for a luxury apartment, while in fact he earn enough money, right? So say, in this case, say for example, like he doesn't tell you your income, and you just try to find a way to collect his data and to estimate his income, right? Something like that. So basically, like the trick here is that you just write down correctly what's the no, what alternative, and then from that you just based on the definition of type 1 error. Similarly, type 2 error, it happened when you fail to reject H naught when HA true, right? True. So basically, in this case, you fail to reject the hypothesis Jacob earn enough money for a luxury apartment. Why, in fact, he not earn enough money, right, for a luxury apartment. So basically, like say, in fact, he cannot get enough money to afford for a luxury apartment, but you fail to reject enough. Or basically, your data conclude that um, you fail to reject enough, which is you cannot reject enough, right? And you basically just say he earned enough money, right? And you support uh, H not, yeah. So basically, like uh, in fact, he not earn enough money for a luxury apartment, but your data suggests that he earned enough money, right? Which means you fail to reject the H not. This is just type 2 error. Published research show that the average person smile 13 times per day. A sociology student studied the attitude of pessimism and optimism in the general population and believed that the average person smiles fewer than 13 times per day. Okay, so it's in sociology, psychology. I think they also do study this type of problems. If we would like to test student claim with a hypothesis test using significant level alpha, okay, 0.03, with the following choices are true. There are 3% chance that mu less than 13. There are 3% chance we will conclude mu equal 13. Okay, but in fact, mu less than 13. And we have C and D too. So basically, like here, we have this, right? This is a key. The alpha, what's the alpha? If you recall, alpha is probability of type 1. We have to make a type 1 error, right? Type 1 error. This is the definition of alpha. So in this case, alpha is 0.03, just a 3%, right? And the problem making type 1 errors, again, the type 1 error, we just have it here, right? Reject A not when true, right? So which means in this case, the property that you reject A not when in fact A is not true, right? So the remaining task now is that we need to know what is the H naught and what's the HA, right? If we can say that, we can specify that, and then basically like we will make the correct choice here. So the studies here, in general, believe average person smile fewer than, okay, average, right? We're talking about the mean, fewer, which is less than 13 times per day. So basically the alternative, which is the mu, which is the average person smile per day, less than 13, right? And versus the no, they always equal sign. In this case, reject a not when it's not true, which is you reject mu equal to, which is property of reject mu equal to 13, right? In fact, given that, in fact, right? Mu less than 13, right? I'm sorry. Reject when in fact mu equal 13, right? 13. Okay. So basically you reject a mu equal 13, which means you support the alternative, right? Reject the no, which means support alternative. So which means you support, right? Support mu less than 13 when in fact mu equal 13. So basically the probability of you support mu less than 13 when in fact mu equal 13 is 0.03. There are 3% chance that we will make a wrong conclusion, which we support the mu less than 13 when in fact mu equal 13. So let's see. So basically like it had to be like two a choice with like the conclusion with a two-part, right? So it should be A here. There are 3% chance we will conclude, so it's wrong. It's not like that, right? There's 3% chance rejecting the no. So hit the lead, right? There are 3% chance we will conclude mu less than 13, right? But in fact, mu equal 13. So basically, this is the correct choice. So let's look at the solution here as well. Right? So it's be D, right? D. Okay, good. So here, the rare events, the sample decision conclusion. According to a study, the typical family for spend 1,000 on groceries in a month. Researchers believe the average amount of money spent on grocery family is not, which is different, right? In a random sample of 20 families, the average grocery bill a month was this much, 1,155, with standards on 35, okay, the 350. Assume the data normally distributed, okay, hypothesis test 5% silicon level is conducted to test average grocery bill in a month for family is not, for is not, okay, so they give all the information here, given a p-value, okay, sorry, they give us the p-value, so we don't need to do much now, we know the p-value. Which is the following appropriate conclusion for this test, okay, select or apply, okay. So we want to test at significant level alpha 5%, right? So this is our alpha 8.05. And the p-value for this test we find out is that 0.06. So if you remember with the p-value, right, to a method to make the decision, you need to look at the p-value to see whether it's less than alpha or not. If it's less than alpha, you reject a no. If it's not, you cannot reject a no, right? So this is how you make a decision with the p-value. So in this case, you can see that your p-value is not less than the alpha, right? It's not less than alpha. 0.06, it's actually greater than 0.05, right? So you cannot reject the node, right? Reject A naught at significant level, 0.05, okay? So we reject A naught, which is wrong. We fail to reject A naught, right? We cannot reject, correct? At significant level, alpha 5%, data do provide sufficient to conclude that. So let's see, be careful here. So here, like what the testing problem is at the HA. So what's the testing problem here? So we do have C and D. We need to be very careful here, okay? Here we have a correct choice B, but how about C and D, right? So here, what he believe here? He believe the average, right? Which is the mu is not, which is different, right? So he's the belief. He doesn't say he greater than less than, right? Mu is the average of spending, right, of a family of four, $1,000, which is his H naught, which is mu equal 1,000, right? So say at significant level 5%, the data do not provide sufficient evidence to conclude that the average grocery bill in a month for a family is a four is not 1,000. So in this case, basically like if this thing happen, right? Do provide right, sufficient evidence to conclude. So which you use support the alternative, right? You support. So in C, basically like in C, which is you support alternative and you reject a no, right? So which means like shouldn't be right. Because here we cannot reject a no. So basically like we cannot conclude the HA correct, right? Here we fail to reject a no. So C shouldn't be the choice. But let's see D. As 5% significant level, the data do not provide sufficient evidence to conclude the average grocery bill in a month for a family of four is not right. So do not provide. So here do not, okay. So basically like we don't have enough evidence to conclude the HA correct, right? H correct, which is we fail to reject A naught, right? So which is just a consistent with the B here, right? The B here, okay. We fail to reject A naught. We have to stay there, right? We do not have enough evidence to reject A naught or to support AA. So either B or D. Let's look at the solution here. Yeah, B and D, right? B and D. Here, a study concludes that 48% Americans report rock music to be their favorite type music. Okay, we talk about percent, we talk about proportion. A researcher believes that the true proportion is much lower than 48%. Yeah, 10, okay, to Americans. And in the sample, 90 of them report rock music to be their favorite type of music. Okay, so they collect data. And whatever they say, and test conducts, so significant level, they want it alpha 2%. These are things you need to look at, right? And the p-value is 0.1018. And I think it's similar to what we did in 4, right? We also need to specify what's the alternative and what's the no, right? So in this case, the alternative here, what he believe here? The true proportion, right? Which is proportion we talk about P, is lower than 48%, right? And no, which is 48, okay? And again, with the p-value method, what you do is that you compare the p-value. So in this case, you see the p-value here this much. It's less than 0.02. So which means you reject A naught, right? A naught. At significant level, 0.03. So it will be A. B, wrong. Number C. At significant level, 2%, the data do provide sufficient evidence to conclude the true proportion of Americans who report wrong music to be their favorite is less than 48, right? It's correct here because you do reject the H naught, right? So which means you support the AA, right? So we have enough evidence from the data to reject A naught as support HA, right? So C here is AC, right? Good. 6. A doctor of fish believes the number of flu cases increasing. The doctor of fish would like to test the claim. So what the claim he want here? The average number of flu cases per day at the doctor of fish is over 6 cases. So average, right? So he's want to prove versus H naught. So put equal sign. Using computed test 187 and the critical value 233. Okay. So here we use critical value and test statistic method, right? So for sure here you should be aware that this is a right tail test. Okay, right tail test. And for the right tail test, you will reject the A naught if the test statistic, the T, right, test statistic, is greater than the critical value, okay? Critical value. Okay. So in this case, your test statistic is 1.87. And the critical value is 233, right? 233. So for right tail test, your rejection region should be T greater than the critical value. Okay, we have that theorem in the lecture note. If you don't remember, please refer to the lecture note. So in this case, you can see this is not met, right? Because 187 doesn't bigger than 233, right? Since this guy less than, so you fail to reject, right? You fail to reject H naught. Okay, so we fail to reject here. So see here, let's see. There is sufficient evidence you cannot reject A naught, right? Which you have to stay at H naught. Right. There is sufficient evidence for the doctor office to reject the no. No. Wrong. There is not sufficient evidence for the doctor, so D, probably. Not sufficient evidence to reject the no because the critical value does not fall into the rejection region. No. I think you don't compare the critical value with the rejection region, right? We compare test statistics, so D also wrong. How about E? There's sufficient evidence for the doctor office to reject no E, because we failed to reject no. Okay, so how about F? There are not sufficient evidence for the doctor office to reject the no, good, because the test that it does not fall to in the rejection region. Okay, so B and F. Okay, have to be very careful. It's a bit like tricky with the language here, but anyway, it helps you to understand the decision testing decision better with the critical value. Okay, method. So we B and F are 6. It's good. Let's see. Addition information for, okay, so we look at the example as a whole. Okay, a doctor testing the claim that average heart rate patients is less than, okay, so I want to test this claim HA, the average, right? The average less than, right? So we change the test in this versus H naught, right? H naught equals 70. Assume population standard deviation is unknown, for sure, right? It's most of the time, right? It should be unknown. Significant level is alpha 0.05, so alpha you want 8.05. A sample of 45 patients have a mean, okay? This is the mean in this standard deviation, okay? What the p-value? Okay, so this is a left tail test, right? A left tail test for mean and sigma unknown. And the p-value is defined by p-value defined by property of t, right? N minus 1. So in this case, you survey 45 people. So in this case, 44, right? And if 45, so this be 44, right? In this, less than the tested value, right? Less than the tested value. Test statistic. Start, right? And the test statistic is calculated by x bar subtract the mu naught, which is 70, right? Divide by S, which is sample standard deviation, square root of n, since k will be 45, right? So you can do TCDF of very small number to this tested value and 44-degree freedom. In this case, your x bar is this is your x bar, right? And this is your standard deviation S, right? S. So you can plug in to get it, right? 68.5. You subtract 70, which is the value under the norm, divided by 4.2 square root of 45, okay? And you can deal with TCDF, a very small number, up to this number, and then 44-degree freedom. But I would suggest just go with the TI because, your TI can help you to achieve this task very quickly. So let me show you how to use the TI with the t-test function to do that, to do this problem, okay? So it will be TI-84, CHCal. Yeah. Go. Okay, good. Can we get it? Okay, that's good. So let's do this. Okay, do it here. So for our problem here, I think let me show you how to use TI. So you do what? Okay, let's. Okay, so you do start here. You go test. You t-test here. And here I remember you don't have the raw data, right? Because if raw data, you put the raw data in a list L1 here. In this case, everything was processed already. You have the mean, you have the standard deviation. So you need to go to start option here. So the mu naught you want to test is 70. The x bar, which is sample mean, is 68.5. Yes, okay, just insert all these things. 4.2. And any 45. And you test it for less than. So see, it's very important to specify the alternative correctly, right? Because if you specify wrong and you choose this option wrong, and you should give the wrong conclusion. So see, if you do this, basically, like you calculate for you the tested value, so that negative 2395 here. So if you plug in here, you should get this value, negative 2395 here. And you do a TCF, very small number, to that negative 2395 and for 44-degree freedom for TCF function, you should get the p-value here. Okay, so basically, but in our case, right, we shouldn't care about this, right? P-value 0.01, 0. Okay, if you keep 3, 0, so 0.01. Say 0.01. So here, like we fail to reject the. So here, let's look at the significant level. We want alpha 0.05. And you see 0.01 is less than 0.05, right? So which means you can reject since, right? Your p-value less than 0.05, less than the significant level, right? Reject A naught, right? So A should be A. B, reject the null. The doctor has sufficient evidence that the average heart rate variation is less than, okay. So when you reject the null, which means you support the alternative, right? So B should be correct choice. Let's look at C wrong. D, what he say? Not the reject or no. The doctor does not have sufficient evidence. Average already no. He reject enough, which means he has sufficient evidence to support his HA, right? HAH. So let's look at another problem here. A tax accountant would like to test the claim that the proportion of individual um, who all when filing the tax is greater than 0.2. If the test this statistic will calculate the 2.05, does the tax accountant have enough evidence to reject the no? Okay. So let's look at this problem here. So what the claim here? Proportion, which is tested for P, who O, okay, proportion O, when filing tax is greater than, right? So we're testing for HA, P greater than. Here P is the proportion individual who owe and when filing the tax, right? Versus H naught equal 0.2, right? So this is the right tail test, okay? It had to be correct here. Right tail. And we want you use one proportion z test here, right? For this case. If the z test calculated, okay, so you get the tested value 2.05. So, and when assume that the alpha is 0.01, okay. So for this problem, you can use either the critical value method and p-value method, right? So if you want to stuck with the p-value method, so let me show you two ways. P-value, right? P-value. And you remember for the z-test, right? The proportion test, the p-value for the right tail test would be equal to property of the z greater than right tail, right? The test static value, which is 2.05 in this case. Okay. This is a test static value. So in this case, you just do a normal CDF. To 0.5, a big number, 0.1, okay? So you do normal CDF to 0.5, big number. So let's see if we have a calculation here so we can save some time. Okay, so two way. Okay, so here they use critical value methods, but okay, let's just stick with the p-value here. It should be consistent, okay? It doesn't matter what. Second distribution, normal CDF here. No matter what method you use, okay? Which is like here you have like 205, 205. A big number, right? 0.1. Enter. Enter. Okay, 0.02. 0.02. Round 3, 0.02. Right? And here you compare 0.02 and 0.01 to make decision, right? So because since 0.02 greater than 0.01, right? So you cannot reject A is not at significant level 0.01, right? So which is the thing? Okay, A, is there enough evidence to suggest proportion individual who all filing tax less than no? You cannot reject A not. So you cannot support HA. A is wrong. There is not enough evidence to suggest proportion individual who own filing when filing tax in less than 0.02. It seems correct. There are not enough evidence, read it again, okay, to suggest that a proportion of individual who owe when filing tax is less than enough. Okay, there is not enough evidence to support the HA, right? That's good. I think it's So it'll be correct. Then is enough evidence to suggest the proportion of individuals who all foreign tax is greater. Also, we have nothing to do greater than CD, right? So will be B. Let's see what they have here. B. What happened here? Fail reject a notch, since fail reject a notch, which mean, oh, I'm sorry. Yeah, it's greater, like greater here, less than. There's a trick here. Okay, I get trick. Okay, because we when we talk about greater, like, okay, so we greater here. There is not enough evidence to suggest the proportion individual of foreign tax is greater than 0.2, right? So A and B had nothing to do with this problem, right? You look at B and D because B and D greater than. And here, like in this case, we use the critical value method to work on this problem. Okay, so which is another way. So here, basically, like this is a right test, right? We just look at it like that, and then you find a critical value because you test at significant level 0.01. So which means like you will use inverse norm to find the critical value, and then you compare your test statistic, right? The test statistic with the critical value. In your test, get 2.05, and it's less than critical value, right? Because in order to make a reject, to make a decision of rejecting the H naught, you need your critical value just test statistic bigger than the critical value for the right tail test, right? So basically, it just gives you the same conclusion, okay? Same conclusion. It doesn't matter what method, but in practice, often people they prefer the p-value method because like it not only like give you the decision, but also it can also tell you in some sense how strong your data, the evidence you have to support your alternative. Here in 9, company claims that the average lifespan of their new light bulbs is 1,200 hours. A consumer advocacy group wants to test his claim. Okay, so they want to test, and then find an average. Okay, conduct hypothesis test. So what they want to test here? Let's see. In finding an average lifespan is 1,180 hours with 150 hours. Conduct hypothesis test. Okay, to determine if there enough evidence to reject the company claim. So in this case, let's see. The company claim this, okay? Want to test the claim. So let's see what should be the alternative here. The alternative is unclear to me. Let's see. Yeah, this problem, this way we state. Let's see what the solution suggests here. Mu different, okay? So the test for different, which is the test is different. So basically, they go against the company claim. Okay, I will go see. Okay, so I think like this problem, yeah, it is like very clearly. But in any case, what they want to test here in this case, they want to test for the mean average, right? Average, and here is the company claims, and because the consumer advocacy, okay, group here. So they want to test the claim. So basically, they want to try to see if they can support this one, right? Mu different 1,200 here versus, okay, versus. So first they just suppose they are correct, right? The claim correct here. And they say if they have enough evidence to reject this guy or not. Okay, so this will be your testing problem. They go against them, right? They just assume, okay, they do correct and see whether they have any evidence to reject that or not. So this will be the testing problem here. And reject, which means different, right? They did say bigger than, less than. And we are testing for an average, right? Average. So say they have a set sample, they get the X bar like this. They have S here, and they have alpha here. Okay. So say so in this case again this is a two-tailed test, right? Two-tailed test, and this is proportion mean test two-tail, right? And for sure, you can always calculate either use the p-value method or critical value method to process this two-tailed test problem. But again, I would suggest just use TI calculator, right? So you need to use t-test with a two-tail, right? T-test with two-tail, and you get your p-value, right? Your p-value. So I would suggest to go with p-value methods because it will be very straightforward. After you get the p-value, all you need to do is just compare the p-value with the alpha. Okay, alpha. So let's see. I want to say sometime here. So let's see. Oh, yeah, it just show you here, right? You will start set and use t-test here, and after you plug in all the number, which is the value under the null is 1,200. The sample mean is 1,180, and the sample standard is 50, and the n is 50, right? And you should get your p-value about 0.0068. And then basically you just compare p-value with the significant level, alpha 0.05. So in this case, it's less than, right? So which means you reject the H naught, and which means you are enough evidence to support the claim, right? The claim, this, okay. So which means you reject the claim from the company, okay? So in this case, there is enough evidence to support the claim the average lifetime. No, there is not enough evidence to support the claim average lifetime. So you reject the no, right? Reject no. There is not enough to support the claim average lifetime. No, so it's wrong. There is not enough evidence to support the claim that the average lifetime company new light bulbs is enough. There is not enough evidence to support. There not enough evidence. There is no evidence. So this is a little bit confusing, but the C more appropriate, right? There is enough evidence to reject the claim that every company new. So we reject the claim, right? But it seems to me that B and C is in some way it kind of pretty much kind of the same way. There is not enough evidence to support the claim. Yeah, I think it is kind of stay in the same side, right? Because you don't have enough evidence to support the claim, right? But basically, the main goal of hypothesis testing is that you can support the HA, right? So C is a better choice here, and it shouldn't be either A or D, right? I would suggest, because again, I didn't give this test, so I did practice set a problem. So if I give, I won't make this kind of confusing choice here. But in any case, the C will be a good choice. Okay, C will be a good choice for here. This problem. So say here, intent, right? Recent publication states that the average percent, so we talk about average percent of oxygen level in the blood healthy adult is 98%. A nurse who measure oxygen saturation in patient believe that oxygen level fall below. Okay, so in any case, we talk about average. Interested in studying this further, the nurse measure the oxygen saturation levels for 50 patients and find a percent oxygen saturation in 97% on average, right? And so it in any way, this is an average problem, right? And with a standard deviation of 1.7%, that's you have to conduct the process using 1% significant level. So basically, like what she believe here, the average, right, fall below, which is less than. So this is published here, right? 98%, right? 98%. You look at the percent, right? So we'll search the H naught. Okay. So her claim will be, maybe you just try it here, right? Let's see. The average oxygen level fall below 98%, right? So this will be B, and this will be A, right? So this is a left tail test, right? Left tail test. And from that, which calculator you use t-test R, right? Function which you t-test, which t-test, right? So it looked like they talk about percentage, but the average of saturation, so the unit will be percent, but it should be t-test, right? And say the following found. Okay, so if you use the correct one, and this will be A will be followed, right? So you can plug in your calculator with a t-test here, with all the measurement here. So see what solution here. So mu 98% or 98, right? So you plug in there, right? And you get this t-test here. So you plug in what you need to provide will be the 0.98 under the no, or 98%, right? You need to provide the X bar. So in this case, your X bar will be 97%, right? Which is the 0.97, your X bar. Your standard sun, which is like 1.7%, which is your S, right? Which is 1.7, which is 0.0717. You plug in your TI calculator. So you plug in X bar with 0.97, the S will be 0.017, and the mu naught will be 0.98, right? So if you plug in all this quantity, and you should be able to get your p-value with this much. And this is much less than the alpha, right? Alpha. So you reject the no. And you reject the no, which is you say there's sufficient evidence to support the claim, right? The average is actually less than 98%. Okay. So a little bit careful with the measurement, the unit here, right? 98% and 0.98. 0.98 here. So let's move to the chapter 10 in the lecture note, chapter 12 in the textbook, a linear regression. Okay. Given the following equation, state the slope, intercept, and evaluate the y when x equals 4. So this is kind of 7th grade problem, right? So this is in your slope here, right? Intercept here, right? And while x equals 4, y will be equal to 5 times 4 plus 23, right? So which is negative 3, I'm sorry. And similarly, so this is a little bit need a little bit work here. Equal to, you add both sides with negative 2x, right? Let's say you switch 2x in the other side, and you need to change the sign of that. Y equal to 6 by 3, which is 2 to 3x, right? So this other time, your intercept will be this, right? So this case, your slope will be negative 5. But this time, your slope will be negative 2/3, right? 0.667. And this is your intercept, right? Intercept. So slope is the thing tied with x. Intercept is kind of the freedom, the free guy, right? It has nothing to tie with. And similarly, you can also find the y as 4, right? And x equal 4. X equal 4, right? 4. 6 subtract a negative 2, right? Okay, let's check. 3, 2. Scatter plot. Brandon keep track of the amount of time he work on homework each week and number of problems he's able to solve. Okay. I think we do have that in the class. So construct the scatter plot. So you just look at it, right? One problem, right? 1 hour. So this guy. So this will be 1 here. 2, 3, right? 2, 3. So he stay here. 3, 5, stay here. 4, 7, stay here. And 5, 9, stay here. Like this. Right? And what the relationship indicated? So it seems like very here we have like strong, it's strong, right? Strong linear relationship. But should be negative positive. The positive, right? Because the more you study, right? The more problem you the longer time you study, the more problem you can solve, right? We call positive. It rises from the left to the right here. So look at the figure here. Similar, right? So D, right? Strong positive correlation. Regression equation. A scientific study on truck drivers' sleeping habits gives the following data table. Use calculator to calculate each following round value for 2 decimal places. Hour sleep per work week, reaction time. Okay. So they want to study the number of hours sleep per work week and reaction time. Okay, reaction time. What reaction time here for standpoint reaction time? I'm not really sure what this study about. It need to be specified further. Okay, sometimes it's unclear what do they mean when they say about reaction time here. But in any case, they want to study they specify the X here, the Y here. Okay, so they want to predict the reaction time based on the hour sleep per work week. Okay, so this is Y and this is X. Use the calculator to compute the reaction equation. So here, with that, you need to do 2 things. First, you need to insert the 2 lists, and then you need to use the linear regression equation function, right? So let's do it. Start, edit, okay. So L1, maybe I should put here hour of sleep per work week. 28, 31, 33, 28, 31, 33. 38, 41. 41. Okay. 100, 105, 125. 100, 105. 168, 150. 168, 150. 28, 31, 33. 38, 41. 100, 105, 125. 168, 150. Okay, perfect. We go start here. Choose the 4 option. The X list is your predictor, right? Which is the work hour, correct. The Y list is your target, right? Which is reaction time. It's correct here already. Okay. So in this case, it will be Y equal 4.986x subtract 40.906. Okay. So Y equal to 4986 4.986x subtract 4906. Calculate the correlation coefficient and interpret its meaning. Okay. So in this case, we don't have that here. For complete output of linear regression, we should have that, right? So if your calculator don't have that, which means you need to do it with correction here, which means make it show it here, right? So you do second 0 here and choose diagnostic on. Yep, and enter. Okay, so now you redo the task, right? Start calculate linear regression equation here. L1, L2, we are here. Okay, good. So now you see your R equal 9, your R square equal A11. That's good. R equal 9, R square equal A11. Okay. So R, big R square, small R square, just the same thing here. A12 actually. If you keep right around that. So the correlation coefficient, it tells us because it's positive, right? So we have a positive linear correlation here, and this is strong, right? It shows strong linear relationship between the sleep hours and the reaction time. And it has a positive correlation, which means if you sleep more, which means the reaction time longer here. Yes, I don't understand really. I don't understand what reaction time mean here. Okay, but basically from this, it suggests such a thing. Okay, and say the R square is 0.812 here. So basically, it tells us like 81.2% of the variation in reaction time can be explained by the linear relationship between the hour sleeper work with and the reaction time. So pretty much it tells us like reaction time can our sleep can serve as a very good predictor, right? When using it to predict the reaction time. So this is the meaning of R square. Okay. So let's look at what they say here. You get 17499, right? 499. Okay, they keep 2. Okay, but just keep 3. Okay, strong positive. Okay. Okay, side count. Okay, just perfect. Okay, so similarly, you can also use this, right, to work for this, right? So here you reference using body weight independent or X, right? Here your X. And brain weight dependent, which is your Y, right? Your target. You use body to predict brain, right? You cannot you take someone brain and weight it, right? You can weight it in the body and then predict their will, right? So this is one way people they study, right? So use something control, you can control easy to get, right? To break something out control, not easy to get. So just follow a similar pattern like what we did in 13, but here you are L1 here, and be careful, okay, when insert all these lengthy list, right? Because you can make mistake easily, and a small mistake will cost you the whole equation, right? So I would suggest again, just show your work, right? You show, okay, put L1 in the body weight, right? In L1, brand L2, right? Something like that, and do linear regression. So in case, you make a small mistake, you still get some credit, right? You just don't put like the equation only, right? But you also be mindful, you have time constraint, okay? But try to show your work to avoid losing credit when, the mistake is just, you maybe it's a 70, you put maybe 7 or something like that, right? 700. So here, like they did everything hard first already here, right? They say weak positive correlation 5.7. So this will be a bad model, right? It's just as if we use body weight to brick brand, which is a bad model. See, 15. A scatter plot shows that where Y in dollar is the cost of personal computer from electronic store and X number of years in 2010. The least square regression equation gives us like this. Interpret the y-intercept of the least square regression. Okay, so the intercept basically it just tells that like nothing else than x when x equals 0, right? X equals 0. When x equals 0, we get the y. It's the meaning of y-intercept. Let's say the predicted cost of personal computer from an electric store year 0 is this. It seems correct to me. In the year 0, oh, year 0. The first basically like no, wrong. After 2010, right? The predicted cost of personal computer from electric store in the 2010 is 900. It seems correct here, right? Because x equals 0, which means the number of years in 2010 is just 2010, right? So I think B should be correct choice. Predicted cost of personal computers is in a year. No, it's wrong. Because in the year 2010 here, which is x0, it be 900, right? Should not be interpreted. I think it can be interpreted by just, x equals 0, right? So let's see what they say. Yeah, B, right, B. Let's say true, false. Correlation with two variables imply one variable cost. No causal in front here, okay? False. The presence of third variable can explain correlation between two other non-confounding. That's good, right? It's what we learned in chapter 1, right? Confounding, right? So say ice cream and brownie, right? The third guy basically just the temperature, right? You get hot, people eat more ice cream, swim more. True, false. The number of firefighters fighting a fire cause increase in size of fire. No, okay. Causal again, right? Don't do causal. Let's look at here. 4, 2, right? Yep. Okay. Good. We pretty much there. See, 19. Oh, yes. Good. Data collected in relationship between time spent playing video games and time spent with family. Okay. Yeah, good. Yeah, this is a good study. Data shown that, okay, so I get backward, right? You should spend more time for a game. How can less time for family, right? Assume that line of best fit is significant in a strong linear relationship here. What would predict the number of minutes spent with family who spend 30 minutes playing game? So you plug in, right? Plug in. So here X is it's unclear about what X is, X and Y, but it seems to me they use game, right? To predict the game time, to predict the family time. Okay. Oh, yeah, you try to predict family time, who's spend 30 minutes, okay? But it should be stay clear, okay? So here you just plug in, right? So y had equal to negative 36 times 36 minutes plus 94.5, right? So this gives you the prediction. So the prediction here, let me see how much they get here. 81.5, good. 81.5. So if we plug in, we get such a thing, right? But now we look at like is the prediction reasonable or reliable? So when we talk about reliable, which means the X belong to the scope, right, of the data. So in this case, like 36 is actually not belong to the scope of the data, right? Because the scope here of the X. So it's not so reliable. We did a little bit extrapolation. So it should be not so reliable, right? How about reasonable? Reasonable, which means we get a Y prediction, is make in the common sense, right? In one common context of problem. So see 81.5 seem reasonable, right? So I think a B will be the choice here, correct choice here. See what they say. B here. Yep. Good. How about this? What would be the number who spent 75 minutes? So same thing, right? You block in 75. And you get 67.5. So in this case, you can see that your 75 belong to the range, so which means it's reliable. The prediction here also seem belong. That makes sense, right? Makes sense. So which means they both reliable and reasonable, right? So you get 8. So again, reliable is stick with the X, whether your X value you want to predict belong to the range or not, right? If yes, it's reliable. No, not so reliable because you require some extrapolation to perform prediction. And reasonable, which means it stick with the Y, right? Whether your Y you predicted is makes sense in a common context or not, right? If yes, it's reasonable. No, not reasonable. So we finished the review class here, and then again, we do have office hours tomorrow, which is the normal class time, right? Normal class time. So I will stay on Zoom. If you don't want to commute to campus, you can ask questions if you have any question related to the test. And I also, meanwhile, I also stay in my office. So in case, you want to stop by and ask me any question related to the material, okay? My office is at 317 Lupton, okay? So thank you so much for your attention, and we stopped here. The